In this video, we comment on a new set of functions called hyperbolic functions. Well, let's start with the definition. There are 6 hyperbolic functions, very much like, in many ways, the 6 trig functions. So we even use like a similar name, hyperbolic cosine with h here. Definition, well, it's average of 2 simple exponential functions. Hyperbolic sine, definition, average of difference. Now, tangent, cotangent, secant, cosecant, they go pretty much like those trig relationships. Tangent is sine over cosine, cotangent is cosine over sine, and so on. Because of the similarities between the relations, theories, results concerning hyperbolic functions and those concerning trig functions, we're not going to do any detailed work in this section, but just to point out again, you pretty much, from mathematical point of view, treat those hyperbolic functions like sine, trig. I mean sine, cosine, so on in trig. The relationship, for example, among all those hyperbolic functions resemble very much those we learned in trig. Only difference we find occasionally is probably a sign. For example, in trig we had sine 2x equal to 2 sine times cosine. Well, guess what? For hyperbolic functions, hyperbolic sine of 2x equals to 2 hyperbolic sine times hyperbolic cosine. So really similar. But this is not true for all relationships. Sometimes there's a difference just between maybe sine. For example, in trig we had sine square plus cosine square equal to 1. While here we have hyperbolic cosine square minus hyperbolic sine square equal to 1. So those are the difference. Sometimes you see a negative sign. Other than that, there's really nothing new. Detailed relationship can be found in the textbook, so we're not going to spend a couple hours to go through all the things like we did with a trig. Now, another reason we don't want to spend too much time, which we don't have a lot of time in this course to do it anyway, is those functions are basically exponential, combination of exponential functions. So if we need to study them, we don't have to treat them as a new kind of a hyperbolic function. We just use the definition and work with the exponential, very simple exponential anyway. So any math we want to do with those guys, we can do with the exponential. If you plug in, those are all exponentials. So this is those hyperbolic functions themselves. Now, in terms of what we do in calculus, we are interested in differentiation, integration. Well, we're not going to say any new stuff because, for example, derivative of hyperbolic cosine is hyperbolic sine. Oh, derivative of hyperbolic sine is hyperbolic cosine. Now this is like the differential relationship we had for trig, sine and cosine. This is a similar with the trig. There's a negative sign. Like I said, you find this occasional differences in terms of a sign somewhere, not all the time. Let's see another differentiation relationship. For example, derivative of hyperbolic tangent. Well, in this case is hyperbolic secant square compared to tangent prime equal to secant square. So that's, well, exactly the same kind of relationship. But then again, some other formulas may have an additional negative sign when we talk about differentiation formulas involving hyperbolic functions. So well, in terms of the formulas, we're not really talking about any new things. These are exactly the same thing, same relationship as what we learned in trig, dealing with trig, or maybe just an actual negative sign or no negative sign. That's that kind of relationship. So this is a differentiation. Now integration from each differentiation relationship we have. For example, here we integral of hyperbolic cosine equals hyperbolic sine plus c, that kind of thing. So even with these new differentiation formulas, integration formulas, there's really nothing new we need to do. We apply formula either, which are very much similar to formulas involving trig anyway, or we can always just get rid of them and use explanation instead. So mathematically, there's really nothing new to how we do things with hyperbolic functions. This is the main reason we're not going to show any example. You're not responsible for any homework problems in that thing, but I do want you to know there's such new set of functions. When it comes to differentiation, same way you approach other functions. If it's a product, by product rule, composite, chain rule, and so on. At any time, if you prefer, you can replace those new functions by the equivalent expression involving exponential only. So now, that's not to say those functions are not important. Mathematically, there's nothing new, no new relationship, not very interesting. But those functions are actually very, very important in real life. For example, if we consider a flexible hanging cable with two ends fixed at the same height, the shape of this cable, sagging cable, is related to actually the graph of hyperbolic cosine. So you can see it's not just some pure mathematical definitions. They are important functions. It's just that first of all, again, we don't have a lot of time, hours, to discuss their properties, identities, hours to talk about the differentiation problems, hours to talk about the integration problems. They're very much like a trig relationship. Alright, this is all we need to know about these hyperbolic functions. No work is required of you, so just to know.